Yeah, do you have any comments or thoughts on like the AGI fast or slow takeoff, or if it's something to even be thought of along those lines?
Fast or slow takeoff for AGI? Okay.
Open source seems to imply slow development over time, which is kind of
Yeah. So based on what I've seen so far, I think that AGI is not going to be a single moment. That's just like what ArcPrize shows, because I think it's very credible that a solution to the ArcPrize will be AGI, and by evidence of all the things I just showed you. And yet I know the first version of the solution to ArcPrize is going to be like highly inefficient. It's going to be very slow. It's probably going to take the entire 12-hour runtime. And it's not going to be very good. We're not going to plug it into YouTube and get super intelligent agents out of it. You're going to have to scale the technology. You're going to be able to decide how do you want to deploy the technology. You know, what I'm most confident about a solution ArcPrize is that we're going to get that new programming paradigm where engineers and programmers will be able to basically teach their programs through example. They'll be able to say, okay, I want to create a program that, given these input examples, can do this, and it can go. And the computer will be able to do that repeatedly and reliably with exacting accuracy. And that's the number one problem that we're seeing at Zapier with on the AI side of things, is our customers don't trust AI because it's not consistent enough. It's not reliable enough to do the same thing over and over. It's failing in ways that that lead them to not trust it. So personally, one of the first things I'm going to do with the solution ArcPrize is go plug it into Zapier and make our technology 100% exacting reliable so that all those small businesses can actually use it now.
All right, let's try. Can you give us a little more of a sense of what the evaluation is for this prize?
Evaluation.
The eval, like how do you win the prize? What are the tests?
Sure. I should have put a slide up for this. I normally do. So to paint a picture with words, the benchmark, these puzzles, there's 100 puzzles in the benchmark, and they look like little IQ tests. You get a grid of input colors and output, and you have to find the pattern, just like those IQ tests everyone maybe did as kids. And your goal is to identify the pattern and then apply it on a test. There's 100 of these. And it's been the same benchmark, same set of 100 tests that we've been using for the last 5 years. It hasn't changed yet today. And I think importantly, these 100 tasks are hidden. There's a private test. No one's seen these 100 tasks. Very few humans have seen them. A couple humans have seen them in order to verify they all can be eaten. But it's an important aspect that they're hidden. And this gives us a very high confidence that every single task we've designed them to be, every single one to be novel. So we know if an AI system can actually beat a majority or most of these tasks, that it will have actually learned how to acquire the skill to beat the tasks within sort of at the test time, as opposed to something that's memorizing solutions to it. In order to get the grand prize, the big prize pot, you have to show that you can write a computer program that can beat 85% of the tasks.
How do you make sure that AGI works for humans and not against them?
tricky one.
This is something I think you have to, this is a problem with all general purpose technology, right? And general purpose technology can be applied for both good and bad things. I think one of the things that makes me sort of optimistic about how humans will figure out how to use this technology in a good way is that, based on the sort of the comments I was making earlier, I think the first versions of this are going to be incredibly weak. And we're going to get a lot of empirical evidence about what these systems can do and can't do. We're going to have to make decisions, I think, as a society about, okay, what are we going to be comfortable deploying that into, and what are we not going to be comfortable deploying that into? My personal viewpoint is that there's a lot of talk about how should we regulate AI today, and I think one of the dangers of over-regulating the AI that we have today is that we are accidentally culling off branches of the tech tree without knowing what they might lead to. I think a much stronger and better innovation policy to make sure we can maximize benefits is by sort of forging our path forward, and as we actually make progress, measuring and assessing, okay, what can these systems do now, what can they not do, and regulate the actual applications of that technology.
What's your estimation on when full AGI will be achieved?
Full AGI. Well, I thought more about when will ArcPrize get beaten.
That one too.
So, before we launched the contest, there was a data scientist who worked at Zapier, the first one we hired, and he had this line that stuck with me forever. He worked on, he was in nutrition, and he worked on this area, subset called survival analysis. And he had this line that went, the longer things go, the longer things go. And this is an idea that, like, if you're trying to estimate how long will something take, you should look at how long it's taken. And the longer it's taken, you should update your priors that way. And so coming in, it was like a 4 or 5 year old benchmark, and so that was kind of my initial estimate. It's like, okay, it's going to take us at least another 4 years to sort of beat this thing. Some of the actual progress, like I mentioned on the slide, has actually been slowing down, so it might have even been longer than that. Based on what I'm seeing today now, since we've launched the prize, because we've actually gotten from the state of the art when we launched was like 32%, and now it's up to 43%. It's gone up 10% since we launched 2 months ago. I think we can get to 50% this contest period. I don't think we're going to solve our prize in 2024. Maybe in 2025. I would be very surprised if you had a time machine and you could come back in the future and say, Mike, we won't solve it before end of 2026. That's kind of my current update on it. I think one of the things that makes it hard to answer your full question of when will we have full AGI is that the main thing that we're going to see improve after ArcPrize is beaten is the efficiency. Jolé's got this definition of AGI that is, it's a system that can efficiently acquire skill. And that efficiency is a spectrum, right? You can sort of peg it in a lot of different ways. You could peg it at brute force search, right? With no sort of efficiency at all. Efficiency equals 0. That's clearly not sort of AI, but it's like one extreme end of the spectrum. Another end of the extreme end of the spectrum you could peg is human level efficiency, where we have seem to have a very high degree of energy efficiency about being able to acquire all these skills and use them very rapidly. ArcPrize, my hunch is it's probably going to start on the brute force side and work its way down as time goes over. But it's kind of an open, I guess, definition of the question of where do you put the peg along that spectrum to say full AGI? Is it at human level efficiency? Is it before? Is it maybe after somewhere? Actually, the system's way more efficient than humans at acquiring skill. So that's an open question still that I don't have an answer to.
If you had to guess, are the techniques being tried today, which one is the seed that leads to this prize result?
Yeah, okay, so the question is, what techniques are people working on today that might lead to this, to the grand prize? So the history of the benchmark, when it was first launched in 2019, there was a capital competition in 2020. Top state of the art then was 20% on the benchmark. So the first score was 20%. From 20 to 30%, the techniques that were working had no AI at all, actually. Remember, this is the era of sort of before language models, before scale, so researchers on Kaggle were just using a hard-coded search, basically. And that got surprisingly all the way up to 30% no AI. From 30 to the state of the art that we're seeing today on the low 40%, folks are doing something called test time fine-tuning. This is roughly what everyone in the research field is doing right now, by the way. They're moving compute from pre-training to post-training. And that's what Jackal is the #1 technique on the leaderboard is doing right now is, he does a pre-train of a model. He's using a 220 million parameter code, open source Salesforce Code Gen T5 model. And inside the Kaggle runtime when it's running, he fine-tunes a new model for every single puzzle that he gets exposed to. It takes the full 12 hours to run to do 100 puzzles, and with a bunch of other bells and whistles, it actually is working. Then we have the top score on the public leaderboard, which is more of a research-oriented leaderboard. There's no prize money attached to it, but you're allowed to use closed frontier models like GPT-4o and Claude and things like this. And the #1 result there is using what I call blast inference plus search. They're generating 2,000 Python programs for every single puzzle by feeding in an image of the ARC puzzle plus a ASCII representation of it. And then they brute force search over all those programs to see which ones could match to the patterns. And then when they find one, they apply it. I think one thing that's interesting about this is I mentioned the alpha proof paper that just came out from DeepMind last week. And so I was reading through the blog post, and they do have some high-level description of the technique they use to get that silver medal on the IMO contest. And they are using basically the exact same 2 techniques combined together to get their result. So I actually think the very next thing somebody should try to do is combine together what Jackal is doing on the private leaderboard with what Ryan is doing on the public leaderboard to do these things together. I would guess that I bet that could get somewhere between the 50 and 60%. I think to get all the way to 85%, all the way to 100, we're probably going to need something that can do some sort of new idea, some sort of new paradigm. My best guess for what that looks like is a deep learning guided program search. Instead of brute forcing thousands of Python programs per puzzle, that's not what humans do. Right? If you introspect and try these puzzles yourself, you look at them and you kind of see maybe 3 or 4 possible answers, and then you test them deterministically in your head. And that's what we're missing. We don't seem to know how to build that yet, where we can use deep learning to guide our search to shrink down the number of samples we need to test.
So what about the consciousness and sentience, actually? What do you think about that?
I think these are orthogonal concepts to general intelligence. Because so one of my bets that I have with the team working on an ARC prize is that I currently think that the grand prize solution, the first grand prize solution ARC, is going to be a 7 billion parameter model or smaller, plus 10,000 lines of code or less. I think the solution to this is going to be very, very small. And I'm pretty confident that like we're not going to look at that system and say, oh yeah, that's like a conscious sentient system. So I think this is starting to reveal to me that I think these like ideas are somewhat orthogonal. I don't have like a deeply like strong research perspective on like what it takes to build consciousness, but I can say with like some degree of confidence that like if you don't think what we have today is conscious, then you're definitely not going to think the solution ARC prize is conscious.
Do you think they're conscious now?
I do not personally.
On that note, let's wrap it up. Round of applause for Mike.
Thank you.